Hey, this is Mr. Mitchell with a video on the periodic table of elements. Periodic table of elements you can see here, and there are 118 elements on the periodic table. Now, most of these occur naturally. Once you get to about 92 or after 92, scientists have to put them together because of their charges. But anyway, these are organized according to characteristics and their atomic numbers. The atomic number is on the top of each one of these on every periodic table you find. For example, hydrogen here has a number 1 on top of it. That's its atomic number. The atomic number represents how many protons are in that element. Now, it also happens that usually has the same number of electrons, but that's not always the case. But it is always the case that it has that number of protons. So, for example, hydrogen here, one molecule of hydrogen has 1 proton, and it should be this, and it will be the same for every one of these. Whatever its atomic number is its number of protons. Now, its atomic mass, you can't see it, but it's going to be at the bottom of each of these, is going to be the average mass of each one. That would be protons plus neutrons. Average atomic masses, protons, and neutrons. Now, the periodic table is almost in order of atomic mass. There are a couple of these down through here where you do have less mass, which is farther down on the table. And originally, a guy named Mendeleev put this table together, and he originally put it in order of atomic mass. But people have since realized that that's not going to be true for all of these, and they are now arranged according to atomic number and the number of protons in each one of these. Now, it's easier to understand compounds. That's whenever you put some of these together to understand their valence. The valence number equals the number of electrons in its outermost layer of electron layers, or electron what's the word for it? Electron orbits. So whenever you have valence number, it's pretty easy to see. All of these in this column have a valence of 1. All of these have a valence of 2. Skip over all these metals. All of these have a valence of 3, valence of 4, valence of 5, and so on. That represents the number of electrons in its outermost electron shell. Its outermost electron shell. And that also helps you determine what goes together. For example, you have the 1s that tend to partner up with the 7s because the outer layer, many outer layers have 8 spaces for electron in its outer shell. So 1s tend to match up with the 7s, 2s tend to match up with the 6s. Now, these that already have 8 in them, yeah, they're not going to match up with much of anything. They are comfortable as they are. You very rarely find a compound with any of these in this 8 valence column. Speaking of sections of the periodic table, we have a section of metals, nonmetals, and metalloids. And if you look at this line of these yellow elements, that is the line between metals and nonmetals. Nonmetals are over here, with one exception. Hydrogen is a nonmetal. You can see it's the color of these over here. Nonmetals are over here, and metals are over here. You can see most everything on the periodic table is a metal. All the red, all the yellow, all the orange, all these blue, all these purples are metals. Now, these that are in yellow are considered metalloids. Metalloids have the characteristic of metal, but they also have characteristics of nonmetals. They're kind of stuck in between metal and nonmetal, you might say. Now, you may wonder, of all these elements, how many of them are solids, liquids, and gases. since most all of them are metal, that also means most all of them are solid. You find very few gases. The gases are in pink, and this little L right here, NOF and Cl, are also gases. But everything else is a solid or a liquid, and there's only two liquids. There's a liquid right here, bromine, and there's a liquid right here, mercury. But besides bromine and mercury, everything else is a solid, except bromine, mercury are liquids, NOFCl, and all these pink ones are gases, and that's what you have. Those are the phases of all of these. Now let's talk a little bit about stability. Stability means how stable these are. The radioactive elements are the least stable. And when you get above 83 or so on the periodic table, when you get above 83, which is about right here, then these others are not very stable. And here's why. In the nucleus, you have positive protons. In the outside the nucleus, you have negative electrons. You probably know from putting magnets together that positive sides and positive sides resist each other. Same thing with negative sides and negative sides. So the more and more positive particles you get around each other, the less stable it stays. It wants to break up. So once you get past about 83 here, there's a tendency for them to break up. And a very highly radioactive element is number 92, uranium. And all of these are radioactive elements from 83 on. Now, from 92, which is uranium on, scientists have actually had to force these others together just so you can make them. And they have particle accelerators which actually do that. So we're about to run out of time of this video, but I want you to know some of these right here, what the atomic number and mass and valence are, where the metals, nonmetals, and metalloids are, a little bit about the phases and the stability of metals on the periodic table and nonmetals on the periodic table as well. Hope you learned a little bit.